Okay, for the next piece, I'll mention that a lot of kids really like the heart. Using a parabola, y equals x squared seems pretty easy. I'll show you what I mean about creating a heart. It will be sideways, and I'll tell you that normally the parabola shape, it faces upwards because it's representing that something is growing. If you throw a negative sign in front of it, every positive value that you have should turn negative and it flips it down. Let me do that again. I'm going to add a negative sign in front of the x squared. And what it's doing is it's taking every number that you had before and it's making it a negative number. So if you see a negative number when you're dealing with this sort of thing, you need to remember to yourself, oh, that's going to be a sad parabola. But we don't want to be sad. We're just trying to have a heart. I will tell you that you can make your heart skinnier by like putting in a 5. That's very skinny 5. You could turn it into a 1 over a 5. Hold on, let me put that 5 where it belongs. 1 over 5. And that makes it kind of a wider parabola. Now, if you add a number at the end, something like this, like I'm going to add 6, there you go. You'll see there's a fatter shape here. And I actually want to zoom out on it and see if I can imagine where this heart is going to live. So when you create the inverse, I'll tell you again, you can select this whole thing and Control C and then Control V will let you paste it back on there and see how the blue and the red live on top of each other. That wasn't my goal. It just makes it easier for me to change that Y into an X and change that X into a Y. Oops, X into a Y. Oh, that's cool looking. There we go. And oops, it isn't an inverse. Sorry, it isn't squared anymore. There you go. I've got my squared. There's my heart, and I kind of like it. I'm just not 100% sure if I'm totally digging it. Let's see if I change this to like an 8. Will I like it a little bit better? Oh yeah, that's kind of cute. Or maybe even if I zoom way out, minus sign and zoom way out, I'm going to turn it into like an 18. So I've got my heart now and it looks perfect to me. I just want you to know, I think it looks great. Some kids don't restrict the domain on this shape and you don't have to, as long as you show restricted domains on 2 other things. So if you want to put some letters inside of here and let these lines sort of, go out into infinity in this direction. You want to let this line goes out into infinity. You like the way this looks, then you certainly can. And it'll still be extra credit, okay? But if you don't restrict the domain somewhere, then I can't give you credit for restricting the domain. So I do recommend that you do that twice. On 2 different sets of something. So we do have an inverse. This is an inverse and this is an inverse, but the inversing is kind of a little bit hard to follow. I just want you to know that restricting the domain on this piece, on this red line, is actually pretty easy to make it stop like right there, because you have this intersection and you have this intersection, and the domain can be really quite straightforward. But the blue one is kind of weird because it's not really a function, and I'll explain that in a moment if you care. We can only restrict it in the following way. Notice how this number here, negative 12.311, that's where I want it to end, where I want it to begin, sorry. Negative 12.311 is less than or equal to x. And boom, it is restricted, but it does have this little tail hanging out on it. And I don't mind that tail if you don't mind it. If it bothers you, you're going to have to watch the second half of this video. But if it doesn't bother you, it's fine. I will say that if you're going to have that tail, then you might as well have the tail on this side too. And what number do you want to end up at? Well, it turns out I'm going to add a little helper line here. I'm going to start it at this negative 12.311. Here we go. I'm going to start it there. My helper line is y equals, whoa, wrong place. Y equals negative 12.311. And notice how I'm intersecting here. And now I can see that I have an intersection there. The beauty of the symmetry of a parabola is that whatever this number is, that number will be the opposite of it. So I want to restrict it in exactly the same way as I did here, with just a straight vertical line. then here's what I do. Ready? I'm going to start at negative 12.311, and it's less than or equal to x, which is less than or equal to, and here's the last piece. There's that 12.311. Now, I'm going to turn off the purple line, and you can see I've done a good job here, but hold on, let me turn it into red so that you really feel like there's a beautiful heart there. And it's like it got tied together, and I think it's pretty, and it doesn't bother me. Some kids, it really bothers you, and you're going to want to move on and watch the rest of this video where I teach you how to cut it off right there so that this part of the tie and this part of the tie disappears. But if you like the way it looks like that, then I'm happy too. And by the way, I'm going to mention, I told you guys to watch this video first because some of you actually want to put your letter right in there. So y equals, let's do like a 3x minus 1. And you can see there's a line in there now. And you could type in the inverse of that line and it would go like this, right? I'm not actually going to type it for you, but it would go like that. And then you're going to have intersections, which you can easily click on, that tells you where to begin that letter and end that letter. And like if you throw an X in here, I totally get it, how you would make that work. In fact, I'll mention, okay, so there you go. Don't forget, before you turn in your project, to turn off the grids and to click save on your graph so that you have it for later. And then make sure that after you've done all of that, that you share that graph. So go throw your letters in there, whatever letters you want right now. For the kid who wants to restrict this domain correctly, you're very frustrated by the fact that your heart looks like it's been tied. Here's what I'll tell you. The upside down parabola is super easy. Ready? I'm going to start at this x value. That's that negative 12.311 that we saw up here. And I could click on that. That's 7.311. So I should have this be a 7 instead of a 12. Ready? Boom. Now I've restricted this piece. It's just half of the heart. But this second part, and this is the math 2 part, by the way, if you're doing the math 2 plus part, if you're trying to do this, what you're going to have to understand is that there is a top half of this equation, and I'm living in the top half right now, and there's a bottom half of this equation. And in order to restrict the domain, you have to type those two numbers in separately. You have to type those two equations in separately. So I'm going to show you how to do that as soon as I find my pen. There we go. All right. So this is the equation that we're working with. And what we've done is the first part of creating that inverse. It's up there, but here you go. This is an inverse that's been started. What we did was we had y equals 1/5, negative 1/5, x is squared plus 18. All right, cool. So if we swap that x and that y already, let's go ahead and just minus 18 from both sides. And so now I see that I have negative 1/5 y squared. This was 0, so I'm going to put the equal sign right here, and I'm just writing this right here so that it looks good, okay? X minus 18. I just moved it around. I like it when I have a y equals equation, and that's what we're doing right now is we are solve for y. Once we get to this step, this solve for y is what we are doing right now. Okay. So how do I get this y to be by itself? I've got a negative 1/5 in front of it. Here's the deal. Multiplying by the reciprocal is absolutely key. So the reciprocal of 1/5 is 5. And because I want it to be positive, I'm going to make that be a negative 5, which means I'm multiplying all of this by a negative 5. Now I'm writing it back here, and I don't really like that. So when I rewrite it, I'm going to put it in front. Ready? Negative 5 times x minus 18. Now, if you're good at distribution, you can distribute that negative 5, but the beauty with Desmos is that you don't have to. You don't have to feel like you need to distribute. Right here, we know that part canceled out. 5 times 1/5 is 1, or 1/5 of 5 is 1. So I just have, ready, y squared equals that negative 5 times the quantity x minus 18. And it looks good. What do we do from here? We take the square root. Now you're like, oh my goodness, I'm not even sure I understand square roots. I'm not very fond of them. I'm going to let you know there's a rule, and we're going to go over this rule about 1 billion times in class. And the rule states that if you have something that is squared and then you square root it, the thing that pops out is whatever was in there. In fact, it works backwards too. If you have the square root of something and then you square that something, you just get the thing. And I'm going to prove it to you that this rule works right now. What is 2 squared? It's 4, right? What's the square root of 4? It's 2. Do you see? Let me try this again. What's 3 squared? It's 9. What's the square root of 9? It's 3. Okay. So now you've seen the rule in action. It means that right here, what do I get? Is I get a y. And I know this looks pretty ugly. So let me do some erasing just so you can sort of see a little bit clearer. All of that turned into that. Okay. And then what? Well, here's the deal. When you square something, you lose a minus sign. So if this had been, ready, if there had been parentheses here and it was -2 times -2, I would have ended up with a +4 because a negative times a negative is a positive. Same thing here. If it was a -3 times a -3, I would have ended up with a +9. So in order for me to know, I'd have to go backwards in time. That's not possible. So what we do is we just say, well, it could have been positive, or it could have been negative, and we just leave it. You're like, are you allowed to just leave things? Yeah, sure. Watch. Desmos doesn't care. In fact, Desmos doesn't even care that I forgot that parentheses right there. I know it was bothering you, but Desmos does not care. Here, let's take a look at what Desmos says. So Desmos says, I can type this equation in, y equals, I'm not going to put the positive in because it's assumed to be positive, and I'm going to type in SQR, and watch this. I'm going to type a T, and then it's going to turn it into a square root symbol. Isn't that cool? Here's my -5, and here is my x minus my 18, and there it is. That's the top half of my equation. I know you can't see it, so what I'm going to do is I'm going to turn it black. Oh, you turn in my heart black. Okay, how about we do blue? There you go. That's the top half of my equation. And I can copy and paste and put, I can copy and paste and put the negative in front of it, and boom, there, and I'll turn this part green so you can see. And I don't know why there's a bunch of lines on here. Hold on, let me turn some stuff off and see if that helps. Yeah, that helps. Turning off the original made it look better. So there's the top half and there's the bottom half, and they have their own separate line now. What you have done, by the way, highly recommend taking notes here. What you have done is you have parameterized the equation. And what that means is that you've separated it into 2 equations. Y equals the positive square root. And I know that there's a bunch of negatives inside of the square root. Don't worry about that. And here is the other equation, y equals the negative version. Here's a -5. Here's an x minus an 18. And ta-da! There you go. So the positive version and the negative version. The positive is hidden and invisible right there, and I don't write it. Okay. Now, let's look at the graph then. So I'm trying to make that graph as big as I can so you can really see it. There's the top half, the positive part, and there's the negative part. And now if I want to restrict this domain, I have this spot, and I can go all the way down to that spot. And what is this spot? It's 7.311. So I start at 7.311, and I'm going to go up to, ready, and equal to x. Now, isn't it kind of funny? I did this on the last one. You maybe didn't notice it. right here, I never put in another number. I've never put in that 18. Why not? Well, it's the vertex. And so the graph, it doesn't go that any past 18 anyways. It's like a hard stop. I mean, I could throw the 18 in there if I want to, less than or equal to 18, because that is an accurate description of the domain. But just as far as the computer goes, the computer knows that it can't draw anything past 18 because there's no values for that function in that area. I know it might be a little bit hard to understand what I just said. I'm just saying, if you felt like you understand that at all, you might want to become a computer programmer, because programmers sort of naturally understand those things. Right here, I definitely want to start at that negative 12.311. And this time, do I have to put in the 18? I don't know. Maybe the graph will stop itself. Let's check. All right, we're going to put in that negative 12.311, and we go up to and including that x, and it did stop naturally. But I will mention to you that on a test, you can't assume that I know that it stops at 18, because I'm a human being. I'm not a computer. I need things to be written down very clearly for me, whereas this computer, it's computing stuff for itself now, and so it knows that it can't draw past that. Anyway, we've got it done. There's the heart, and it is quite pretty, and I hope you like it, all right? This is the one where I was not restricting that line, and this is the one where I am restricting that line. Why did this piece disappear? Because instead of letting the domain start at negative 12.311, which is what I said right there, that it could start there, I told it this top half of this line should start there instead. And how come I couldn't just tell this to stop at 7 point, whatever this intersection is, which I'm having a hard time clicking on it again, 7.311. How come I couldn't do that? Well, let me turn off this bottom half. Let me turn this guy off. If I had done that, instead of having like a vertical line, that helper line be right here, let's change this into the x value. Instead of having this line be here, I wanted to move it over to there. It would erase not just this top half part, right? This top half part, it would also erase this bottom half part too. So let's put it in so you could see it. Let me put in that 7.311, and you could see now that it means that my heart didn't finish drawing. And we don't like that. I mean, unless you're going for that. If you want to go with that and turn that into part of like maybe you could throw a letter down here and it's like a heart got tucked inside of a letter. These are all choices that you get to make, and if you like it, you can do it. I'm going to put the negative 12. I'm going to turn this one off again because I fixed it to where this top half went exactly where I wanted to, and that bottom half went exactly where I wanted it to, and I don't even need that helper line anymore. And